So today we're going to do our first lesson on probability. And probability is really just the study of chance behavior. And so when we're talking about random behavior, that's really what we're saying, is that it's all behavior that has some chance element involved.
Hopefully you watched the first video that was a little long, but it covered a lot of vocabulary and terminology that we're going to need throughout this lesson. And this video is just a continuation of that, and we're going to do 4 worked out examples that you might see on your homework problems.
So now we're ready to dive into 4 example problems, and these are found on the notes worksheet that goes along with this video if you want to work along with it. So example number 1, basic probability problem. So we have a jar of marbles. We always have jars of marbles, and there are 14 red marbles, 8 green marbles, and 12 blue marbles. So you're asked A, B, and C, what's the probability of selecting a green marble? Part B, a red or a green marble, or part C, a red and a green marble. Okay, so here we go with the answers. So what's the probability of selecting a green marble? So first, when we do this problem, the first thing we have to do is add up all the marbles in the jar to get the total. Then we need to calculate the probability using our formula, the number of ways the event can happen. So in this case, the number of green marbles we have out of the total number of outcomes, so the total number of marbles. And so we get 8 green marbles out of 34 total. That simplifies to a fraction of 4/17, which is about 0.24. And then part B, what's the probability of getting a red or a green marble? So we still have 34 total marbles, but now we have 22 because we added up the red and the green marbles together. So we get 22 out of 34, which simplifies to 11/17 or 0.65. And then C, what's the probability of selecting a red and a green marble? Again, I don't think we had any stripes or polka dots or any kind of funky marble colors. So 0, it can't happen. So example number 2, let's get into a little bit more challenging problems. So example number 2, the following data table summarizes the people aboard a cruise ship categorized as passenger or crew, and it indicates if they're a U.S. citizen or from a different country, so not a U.S. citizen. A lot of times you'll be given a probability problem that's formatted like this in a table. We call this a two-way table because there's 2 different variables that they're evaluating. In this case, whether they're passenger or crew, so type of person on the ship, and then whether they're a U.S. citizen or a non-U.S. citizen. And that's expressed in a table form. And this happens a lot in probability problems for math class, as well as you'll see this in news articles and all sorts of other information that you might read or see on TV. So in this case, what's the probability that an individual is a U.S. citizen? And then B, what's the probability that the person is a U.S. citizen or a passenger? And C, what's the probability that an individual is not a U.S. citizen and is a passenger? So a passenger who is not a U.S. citizen would be another way of reading that part C question. So when you're given these kinds of problems, the very first thing you want to do when you're given a table is that in the problem we were given, it didn't have totals. So we want to add a column over here for totals and a column at the bottom for totals and add up the number of passengers, the number of crew, and then if we add to the right here, we add the number of U.S. citizens. So that's a total of 160 U.S. citizens and 40 non-U.S. citizens. And so when we add our table, when we add in our vertical direction this way, and when we add in the horizontal direction this way, we should get the same exact numbers, which all add up to 200. So that's nice because it's kind of a nice, easy number to work with. So then part A, now we can do the calculation. So once we have our totals, it's a lot easier to do our calculations. So for A, what's the probability that an individual is a U.S. citizen? So in this case, I'm going to look at the total up here. So I need the total number of US citizens out of the, what I call the total. So the total of all the people on the ship. So I have 160 US citizens out of 200 people on the ship. So that simplifies to 4 out of 5, or 0.8. Okay, so part B, what's the probability that an individual is a US citizen or a passenger? So for these problems, I really recommend using a highlighter, using 2 different colored highlighters. And what you'll see is that if you take your highlighter and we highlight the 2 different options we want. So we want US citizen, right? So we're going to take US citizen, and that's this row right here. Oops, sorry, crooked. And then, or a passenger. So we'll do passenger in yellow. And so passenger would be these guys that go this way, right? And where they intersect, we get blue and yellow. That's going to give us the green. You want to count up, just count up, not the totals, but what are in the boxes here, and add them together, because remember, an or problem, they can be a US citizen or a passenger. And remember, when you have an or problem, you're supposed to think in your head, okay, that means a US citizen and or a passenger. So when I add these up, I'm going to take all the passengers, so I have 110 plus 10, or 120 passengers, and then I have to include all the US citizens. So I have 160 US citizens, but I don't want to count these guys twice that are showing up in green here. So I'm just going to add up my passengers and then anybody that I haven't counted already, which would be my crew who are US citizens. So if I add 10 plus 110 plus 50 out of 200, that's going to give me 170 out of 200. And when I simplify that, I get 0.85. So about 85% of the people on the cruise ship are either a passenger or a US citizen, or both. Okay, then on to part C. So part C, what is the probability that an individual is not a US citizen and is a passenger? So this is worded a little bit funny. Sometimes you'll see probability problems sound a little funny, but basically I want the probability that an individual is not a US citizen. So those are these on this line here. So I have 10 passengers and 30 crew members are not US citizens, and they're a passenger. So of our 120 passengers, I have 110 that are US citizens and 10 who are not US citizens. In this case, I'm looking for that intersection where my answer has to be both of those things. So what I'm looking for here is the intersection of passenger and not US citizen. So I just want this number 10. That's all I want, because it's an exclusive problem, meaning that you have to be both to get into the club. So you have to be both a not a US citizen and a passenger to get into our club for the and problems. So we have 10 out of the total number of people on the boat, which are 200 people. So 10 out of 200 simplifies to 1 out of 20, and that is 0.05, or about 5%. So another way of thinking about what this problem is asking is that if you throw all these people into a box and you shake up the box, and you reach in the box and pull out one person, what is the probability that that person is going to be a passenger and not a US citizen? So your answer is 1 out of 20, which is about 5%. You have a 5% chance that you're going to reach into that box of people, pull one out, and get somebody who's a passenger and not a U.S. citizen. So moving along, example number 3. So here we have a word problem. There's no picture, no table. So for these, we're going to talk about some strategies to tackle these kinds of problems. So example number 3. In a certain kindergarten class of 26 students, 10 of the students like to play Frisbee, and 5 of them like to play tag. There are 3 students who like to play both. They like both Frisbee and tag. So what is the probability a student chosen randomly from the class likes to play Frisbee or tag, Frisbee and tag, or doesn't like to play either one? Okay, so let's talk about how to tackle these problems that don't have any pictures or anything. So first thing you want to do, make a table. So they didn't give us one, but that's okay because we can make one. And we need to look at the problem and see what are we talking about. So we're talking about kindergarten students, and we have 2 variables here. We have Frisbee and tag. So I'm going to make my table, and I'm going to have Frisbee, not Frisbee, or no Frisbee, and tag, no tag. So they're always going to be kind of a yes or no kind of situation. And then I start filling in my table with what they gave me. So the next thing is, I know I have 3 students who like to play both. Well, both, that's the and problem. So that's where I have Frisbee intersects with tag right here. So that's where the 3 goes. And then 10 of my students like to play Frisbee. So 10 total, that's down here in the total section. 10 like to play Frisbee, and 5 like to play tag. That goes in the total for the tag row over here. And then I know that there are 26 students total, and that's my total down here, 26. And then using this, it's kind of like a Sudoku puzzle if you've ever done that, but you're just going to figure out what goes in the blank. So I know 3 plus something has to equal 5. So 5 minus 3, that's going to be 2. Same this direction, 3 plus something has to equal 10, so that's going to be 7. And everything's going to have to add up. So 10 plus 16 is going to give me 26. And so when I fill out my table, I'm just kind of deriving what the missing information is. And so when I add up my rows, 3 plus 2 is 5, 10 plus 16 is 26. So then the next thing I did was I said 26 minus 5, I get 21. And I can say 10 minus 3 is 7, and that's how I would get this 14 and figure out this has to be 16. So they all have to add up, up and down and sideways. Now I can tackle my problems, and now that I have my table, it's just like the problem we did. So likes to play Frisbee, that would be 10 out of 26. Likes to play Frisbee or tag. So remember we want to do Frisbee or tag and where they intersect, but don't count anybody twice. So you're going to just add up the 7, the 3, and the 2. So that gives me 12 out of 26, which is 0.38. And then C likes to play Frisbee and tag. That's 3 out of 26. And D, they don't like to play either. So the one when it says doesn't like to play either, that's like neither. So that means no tag, no Frisbee. No fun, but hey. So that would be 14 out of 26, or about 0.54. So again, when you're just given the words, remember we weren't given any picture here, so what we did was we drew a table. You can also answer these problems with a Venn diagram, but I really think that using a table is a lot easier. If you want to use a Venn diagram, you can Google that, or maybe we'll come back and address that at a later time. Okay, and this is the last type of problem that you might see on your homework. So example 4, you have a spinner that has 12 equal parts or 12 equal spaces. They're numbered 1 through 12. And again, you might not be given a picture for something like this. So if you are not given a picture, sometimes it's easy if you draw it out. They're pretty simple to draw. So you're spinning the spinner one time. What is the probability that A, it lands on an even number, B, it's a multiple of 2 or 5, and C, it's a multiple of 2 and 5. Okay, so here we go with the answers for number 4. So if we spun the spinner one time, the probability that we get the spinner to land on an even number, those are 2, 4, 6, 8, 10, 12. So there's 6 of those numbers out of 12 numbers, so that's 1/2. And then B, the result is a multiple of 2 or it's a multiple of 5. So again, remember that on these problems, when you have the or, you want to be thinking it's a multiple of 2 and or it's a multiple of 5. So if you list the multiples of 2, you get 2, 4, 6, 8, 10, 12, and or a multiple of 5, or multiples of 5 are 5 and 10, but be careful because you don't want to count that 10 2 times. You only want to count it once. So our final answers would be 2, 4, 5, 6, 8, 10, 12. And so that gives us 7 numbers out of 12, which is about 0.58. And then lastly, C, the result is a multiple of 2 and a multiple of 5. So remember with and, that's the exclusive one. So it has to be both. You're only looking for the intersection. So you want the number that shows up in both sets. So 10 is the only number that shows up that's a multiple of 2 and a multiple of 5 in this case. So you would get 1 out of 12, which is about 0.08. Incidentally, that little squiggle here, you know that means approximately. So that tells you I'm rounding it to 2 decimal places. So again, if you're giving your answer as a decimal, you want to make sure and give us 2 decimal places in your answer. And that way we know that it's a little bit more exact than if you just round to 1 decimal place. That's just not enough information. So hopefully this helped, and we'll put more notes up for the rest of the unit soon. Take care. Have a great day.